Hello everyone! Input-output theory was initiated by Vasily Leontiev with the publication of his article in 1936 year. Vasily Leontiev presented two models, closed model and open model. This video covered only closed model. Closed model is the model without demand matrix. No demand from outside the N industry under consideration. So we will discuss today closed Leontiev input-output model. This formula presents closed model. As a second formula, help for us find solution of Leontiev closed model. What is solution? We have to find variables from variables matrix and x, y, z. It is X matrix or just x, y. This situation will depend on given information. We remember this is formula I minus A times x equals 0. We work with matrix theory. So A is input-output matrix, I is a density matrix, O is zero matrix. The first example, we have given information input-output matrix and we have to find a solution of associated input-output model. So it is closed, we have given information, it is closed economy. So our given matrix, it is A matrix. Step 1, we have to find matrix I minus A. With I, it is a density matrix, A, it is output-input matrix, given matrix. So it is equals 1, 1, 0, 0, minus our given matrix, we have 0.54, 0.46, 0.06, and 0.94. So we subtract and we have 1 minus 0.54, it would be 0.46. The second element minus 0.06. After we have minus 0.46 and we have 1 minus 0.94, it would be 0.06. So it is our matrix I minus A. Now we follow our formula and we have to write equation in matrix form. So I minus A, we took from the first step, it would be 0.46 minus 0.46 minus 0.06, 0.06 times x. X, we remember, it is variable matrix. We have here input-output matrix, size of input-output matrix 2 by 2. So variable matrix has size 2 by 1. Only two variables, x and y. Equals 0 matrix, it would be 0, 0. This matrix form. Next step. We have to convert matrix equation to system of linear equation. The first equation would be 0.46x minus 0.06y equals 0. And the second equation minus 0.46x plus 0.06y equals 0. It is our system of two linear equations with two variables. Step 4. We have to find augmented matrix of our system of linear equation from step 3. Augmented matrix would be 0.46 minus 0.46 minus 0.06 and 0.06 and constant matrix 0, 0. This is augmented matrix. And now we have to find reduced row echelon form for system of linear equation from step 3. Reduce row echelon form. I use technology to find reduced row echelon form. This video remind you how reduced row echelon form can be found using graphing calculator. So you will use your calculator and you will have answer 1 minus 0.13 0435 0000. So we can see we have dependent system. Dependent system, we remember, answer for dependent system must be written in parametric form. So we have to find parametric form. It is next step. Last step, we have to write answer. So our reduced row echelon form 1 minus 0.13 0435 0000. So we have here two variables, x and y. Now we can see y variable, we have 0, 0, 0 last row. So variable y, it would be parameter r. Now we have to work with the first row. The first row we can see it would be 1 times x minus 0.13 0435 times y equals 0. Our goal, we have to express x. So we must add for both sides 0.13 0435 y plus 0.13 0435 y. So now we have x equals 0.13 0435 y. I remember what is y. Y, it is parameter, and I have to write answer in parametric form. So now we write our x using parameter r. 0.13 0435 r. So answer it would be, we can write in matrix form using parameter, so it would be 0.13 0435 r and r. If you don't understand matrix form, you can write answer like x equals 0.13 0435 r and y equals r. With r it is parameter. The second example, we have here closed input-output model. So it is closely ONSIF model, but we have here matrix input-output has size 3 by 3. It is our A matrix. We will follow absolutely the same plan like previous example. So it is our matrix A, input-output. Next step. The first step of solution, we have to find matrix I minus A. With I, it is a density matrix 3 by 3. 0 must be here, 0, 0, 1. It is a density matrix minus given input-output matrix. 0.22, 0.4, 0.38, 0.07, 0.05, this point, 0.88, 0.7, 0.32, 0.61. Okay, so now 1 minus 0.22 give us 0.78. Next element 0 minus 0.07 give us negative 0.07. After negative 0.07. After negative 0.4. After we have 0.95. Next negative 0.32. Negative 0.38. Negative 0.88 and 0.39. It is our matrix I minus A. Now we have to write matrix equation So expression I minus a times x equals 0, we have to write in matrix form. We write our matrix I minus a 0.78 minus 0.7 minus 0.07 minus 0.4 minus 0.38 0.95 minus 0.88 minus 0.32 0.39 is matrix times variable matrix x, y, z. Our variable matrix has three variables equals 0 matrix 0, 0, 0. The third step, we have to convert matrix equation to system of linear equation. It would be 0.78x minus 0.07y minus 0.07z equals 0. Now minus 0.4x plus 0.95y minus 0.32z equals 0. Now minus 0.38x minus 0.88y plus 0.39z equals 0. So next step, we have to find solution this system of linear equations. We have to find augmented matrix in reduced row echelon form to solve this system of linear equation. So augmented matrix has form 0.78 minus 0.07 minus 0.07 minus 0.4 0.95 minus 0.32 minus 0.38 minus 0.88 0.39 and the constant matrix 0, 0, 0, constant column. I use technology to find reduced row echelon form. This video reminds you how reduced row echelon form can be found using graphing calculator. So my reduced row echelon form have matrix 1, 0, negative 0.12, 4, 6, 8, 4. The second row I have 0, 1, negative 0.38, 93, 41, 0, 0, and last row 0, 0, 0. You can see we have last row 0, 0, 0, so it is dependent matrix and we have to write answer in parametric form. Reduce row echelon form from the first step equals 1, 0, negative 0.12, 46, 84, second row 0, 1, minus 0.38, 93, 41, and we have 0, 0, 0, 0, 0, 0. So it is matrix 3 by augmented matrix 3 by 4, but we have here, we remember, three variables. So x, y, z. Z variables, it would be parameter, we set z equals r. So let z, it is parameter r. Now we work with the second row. The second row we can see it would be coefficient 1 of y. So 1 times y minus 0.38, 93, 41 z equals 0. We can express y. We add both sides 0.38, 93, 41 z. So y equals 0.38, 93, 41. What is z? We said z, it is r, parameter r. So it is our y, it is z, and we go work with the first row. So 1, it is coefficient of x. 1 times x, I change color, 1 times x plus 0 times y, so it is 0, minus 0.124684z equals 0. Now I have to express x. I add to both sides 0.124684z plus 0.124684z. We can see x equals 0.124684 z. What is z? Z, it is parameter r. So now we can write x equals 0.124684 r. This is our x. So we can write answer in matrix form. It would be 0.124684r, 0.389341r, and z equals parameter r. This answer in matrix form, in parametric form, because we use parameter r here for our example. Thank you for watching and see you soon.